You have control over your cloud resources. Great. But how do you actually use that control? How do you create a virtual machine, configure a database, set up networking, manage permissions, or deploy an application? You need an interface, a way to communicate your intentions to the cloud platform. You need something standing between you and the infrastructure that translates what you want into what actually happens. These interfaces are called control surfaces, and they're more important than most people realize. Because the control surface you choose doesn't just affect how you manage the cloud, it affects what you can manage, how quickly you can manage it, and whether you can manage it securely and at scale. Today, we're exploring control surfaces in cloud computing, the layer between you and your infrastructure that determines how control actually works in practice. Let's dive in. A control surface is any interface or mechanism through which you interact with and manage cloud resources. It's the touch point, the boundary where your instructions meet the cloud platform's execution. Think of it like the controls in a car. You have control over the vehicle. You decide where it goes, how fast, when it stops. But you exercise that control through specific surfaces: the steering wheel, the accelerator, the brake pedal, the gear shift. These are your control surfaces for the car. In cloud computing, control surfaces are the web consoles, APIs, command line tools, configuration files, and automation frameworks you use to manage infrastructure. They're how you translate "I want a virtual machine with these specifications in this region" into an actual running VM. Here's why this matters. You can have all the control in the world, but if your control surfaces are limited, hard to use, or don't support the operations you need, that control becomes theoretical. Control surfaces determine whether your control is practical and usable. Different control surfaces offer different capabilities, different levels of automation, and different trade-offs between ease of use and power. Understanding your options is fundamental to effective cloud management. Let's break down the major types of control surfaces you'll encounter in cloud platforms. First, graphical user interfaces, web consoles and dashboards. AWS Management Console, Azure Portal, Google Cloud Console. These are visual interfaces where you click, drag, configure, and deploy resources through a web browser. They're intuitive, visual, and accessible to people who aren't developers. You can see your resources, navigate through menus, and make changes without writing code. Second, application programming interfaces, APIs. Every major cloud platform exposes APIs that let you programmatically manage resources. Instead of clicking through a console, you make HTTP requests to API endpoints, sending JSON or XML payloads that specify what you want. APIs are how everything else connects to the cloud. They're the foundation layer. Third, command line interfaces, CLIs. Tools like AWS CLI, Azure CLI, and G-Cloud provide terminal-based access to cloud services. You type commands, and they translate those commands into API calls. CLIs are faster than GUI consoles for experienced users and enable scripting and automation that GUIs don't support well. Fourth, software development kits, SDKs. These are libraries for programming languages, Python, JavaScript, Java, Go, that wrap the cloud APIs in language-native code. Instead of making raw HTTP requests, you use methods and objects that feel natural in your chosen language. SDKs make it easier to integrate cloud services into applications. Fifth, infrastructure as code tools, IAC. Terraform, CloudFormation, Pulumi, ARM templates. These let you define infrastructure in configuration files or code, then deploy that entire configuration as a single operation. Instead of creating resources one at a time, you declare the desired state, and the IAC tool makes it happen. Sixth, policy engines and guardrails. Tools like AWS Service Control Policies, Azure Policy, or third-party governance platforms let you define what's allowed and what's forbidden. These control surfaces work by constraining other control surfaces, preventing users from creating non-compliant resources, even if they have permission. Each control surface has strengths and weaknesses, and most organizations use multiple surfaces for different purposes. There's a fundamental divide in control surfaces that shapes how you manage cloud infrastructure: manual versus programmatic control. Manual control surfaces, primarily GUI consoles, are designed for human interaction. You point, click, fill in forms, and submit. They're intuitive, visual, and great for exploration, learning, and one-off tasks. Need to quickly spin up a test VM? The console is perfect. Want to investigate why something isn't working? Visual dashboards are invaluable, but manual control surfaces don't scale. Creating 10 resources through a GUI is tedious. Creating 100 is practically impossible. Manual processes are error-prone. You might configure 9 resources correctly and misconfigure the 10th, and manual changes are hard to track, audit, and reproduce. Programmatic control surfaces, APIs, CLIs, SDKs, IAC, are designed for automation. You define what you want in code or configuration, and the platform executes it. This scales infinitely. Deploying 1 resource or 1,000 resources takes the same effort once the code is written. It's repeatable, auditable, version-controlled, and testable. Here's the pattern successful cloud teams follow. Use manual control surfaces for exploration, learning, and troubleshooting. Use programmatic control surfaces for anything that goes into production, needs to be repeated, or requires consistency. The industry is moving decisively toward programmatic control. Infrastructure as code, GitOps, declarative configuration. These are becoming standard practices because programmatic control surfaces enable the speed, scale, and reliability that modern cloud operations demand. So why do control surfaces matter beyond just different ways to do the same thing? First, they determine your operational speed. GUI consoles are slow, APIs and IAC are fast. If you're managing infrastructure manually through a console, you're bottlenecked by human clicking speed. If you're using programmatic control surfaces, you're limited only by API rate limits and automation execution time. Second, they affect consistency and reliability. Manual control surfaces introduce human error. Programmatic control surfaces, when done well, execute the same way every time. That consistency is critical for security, compliance, and operational stability. Third, they enable or prevent automation. If your control surface is a GUI, you can't automate. If your control surface is an API, CLI, or IAC tool, automation becomes possible. And in modern cloud operations, automation isn't optional. It's how you achieve scale. Fourth, they shape your security posture. Some control surfaces offer better audit trails, better access controls, better integration with security tools. How you control your infrastructure affects how you secure it. Fifth, they impact vendor lock-in. GUI consoles are provider-specific, but multi-cloud IAC tools like Terraform work across providers, reducing lock-in. Your choice of control surface affects your flexibility. And finally, they determine who can manage infrastructure. GUIs are accessible to less technical users. APIs and IAC require coding skills. Your control surfaces define who on your team can operate the cloud. Control surfaces are the interfaces between you and your cloud infrastructure. They're the mechanisms through which theoretical control becomes practical action. From GUI consoles to APIs, from CLIs to infrastructure as code, each control surface offers different trade-offs between ease of use, power, scalability, and automation. Understanding your options and choosing the right control surface for each task is fundamental to effective cloud management. And remember, you can have all the control in the world, but if your control surface doesn't support what you need, that control is useless. See you in the next one.